Good afternoon, everyone. Can you hear me well? Yeah? Okay. Good afternoon. I'm Hannes.
I'm Gabriel.
And we used to work together at a company called Freeletics, so just in case you're wondering. And I say used to because now I'm working at OneFootball, whereas Gabriel is still at Freeletics. And we were talking, or we are going to talk about things that we have introduced at Freeletics to help our engineers to become more productive. What it means, we'll figure it out in a minute. But important is one thing that I want to shout out, which is it's important that you need to measure something, right? Who of you works with OKRs in a company? Please raise your hand. Who has technical OKRs, like for engineering? Do you notice something? Like as soon as you start talking about OKRs, like the mood shifted dramatically, you know? Yeah, that's what I'm here for. So no worries, let's be clear about this one. This talk is not about OKRs. I know we are here on a tech conference. We will really talk about technical stuff, like more Gabriel, because he's, I'm engineer manager, let's be honest. Like I have no clue about this stuff here. But we will go really, really deep into some technical aspects. There will be a lot of questions, probably, if you don't understand the slides. That's all right, that's kind of expected. But what we also want you to get at is, out of this talk, some kind of inspiration. So we will not show you kind of our metrics or our KPIs has improved by X, Y, Z. But we will show you some KPIs that we were looking at to give you, again, inspiration. Because what we have also learned from when we talked first with our friends outside of our company about this talk, they were talking to us, oh, that's great, I will try that in my company. And that didn't make sense at all for them. So there is one very important aspect to what we are saying here. It really depends on the context. And just to provide you context about Freeletics. So Freeletics is a fitness app. It's about doing bodyweight exercises, HIIT, stuff like that. Or not HIIT, that's the negative stuff, sorry. The HIIT, that's what I wanted to say. But what we have figured out are those 4 things that are here in color. Like peer review time, or in general, what you would like to achieve is like, you know, it takes less time to write code, right? It takes less time to build features. But how do you measure that? Like one feature is more complex than the other one, right? But we have found out some, and again, that's Freeletics, in the context of Freeletics, we have found out some other KPIs that we were interested in. One is peer review time, like how long does it take to do a peer review? Use a peer reviewer when you get assigned a peer review, and you start looking at it. How long does it take until you kind of give an approval, or until you have understood the code, actually? That's more the specific one at Freeletics. Again, depends on the context. The other ones, rework rate, or in other words, how many bugs are there. For example, team A ships a feature. Within the next 30 days, how often do you change the code that is part of this feature? And with changing, I mean not like improving, adding more features, but because there were bugs, there needs to be refactoring, the code was complex, there were crash reports, stuff like that. Again, depends on the context, but if you are able to measure something like that, you could get some great insights. Also, disclaimer, it depends on the company size. Like, we're Freeletics, we're not Google. Like, we don't have, like, millions of engineers who can work on that. Just to provide more context, we're talking about 15 Android engineers spread across four teams, cross-functional teams with iOS backend engineers and so on. But yeah, keep that in mind. Other stuff like repetitive tasks, like how many manual steps do you have to do to get something built? Time to onboard new joiners, like if you want to grow as a company, or there are leavers, there are new joiners, like how long does it take to get them productive? How we can measure that, we will talk a little bit more about some concrete examples along the way and give you then all the technical answers by Gabriel, actually. I will also talk from time to time, no worries, but yeah, listen more to him. There are also some other KPIs that we have not highlighted, which are not necessarily here part of this talk. For example, build times, something that you can totally optimize for, you can measure, but not what we want to talk about. Like, we're not going to talk about Gradle and stuff like that too much, so just to be clear from the very beginning about this. So the next, how do we approach this? And funny enough, that's actually not so different from what you're doing in regular product development. Like, you can do discovery. You can build MVPs, and I'm not meaning model view presenter. You can build a very, very small iteration. You can iterate over it. And you can get a lot of inspiration, actually, from these product books, like the Lean Startup Principles. They work, actually, also for engineering productivity. You just need to kind of try to map what is in there into your company's context, but in the context of engineering. Who are your users? You need to understand your users. Users are not like the end customer using the feature of your company. Your users are the other engineers, right? And you can do a lot of those stuff, like user interviews. If you are at big scale, you could even consider running A/B tests. Not so possible at our scale, but think about that. Like, there's a lot of kind of things that you may have not seen or not thought about before in the context of engineering productivity. And that's what this talk is about. It's really more about getting you just some inspiration. Go out here, think about your company, about what you do in your Android code base, and maybe there are some things that you can then apply there as well, or not. Let's see. Over to you, Gabriel.
Yes. We want to start with giving a bit more context about the Freeletics code base. Right now, or like at the time I wrote the slide, we were at exactly 600 Gradle modules. We use unidirectional data flows to like architect everything. Anything that's newly written is written in Compose. For dependency injection, we use Dagger and Anvil. Navigation is mostly AndroidX navigation, but we'll talk a bit more about that later. And then we have fragments because the app is very old, like 5+ years old. So we cannot just get rid of them easily. So we still have them for legacy reasons, even though we don't really want to. These are the three main components that basically each of our feature modules have. There's a navigator, a state machine, and a composable for the UI. So we have actions going from the composable to the state machine. The state goes from the state machine to the composables. And then if you want to navigate somewhere, like the state machine, based on some action, calls the navigator, which then sends events to the composable, and there the actual navigation happens. This is where an engineer would write their code, these three main components. There's also some other stuff going around there. So like there's the mentioned fragment still there. We also still have view models to like keep stuff alive during configuration changes. And then Dagger does some stuff. We'll get to that also. So to get to the actual part of the talk, we noticed some issues. So in case of repetitive tasks, each new module that we create requires a lot of classes. Like there's the three I just showed, and the view fragment, the view model, some Dagger stuff. That's very annoying, very manual. It also makes it harder to onboard because everyone does these steps slightly differently, like creating a package slightly differently, naming classes slightly differently. So if a new joiner comes, they ask themselves, OK, is this how I do it? Is this how I do it? And we wanted to solve this. And for this, we created some tooling. So we have this command line tool called Droid, and you can basically just say Droid new module and then give it a path. And this would create a new feature module called example. And the IDE would look something like this. So it creates all the folders, all the classes. And the three main ones are the ones I already showed. So you get a navigator, you put your navigation code into that. You get a state machine, there you would write your business logic, and then a composable for the UI. Some learnings that we had while developing tooling are, it's best to start with simple and easy to build tools. So Droid, for example, started with just creating the folder structure and the build files, and all the code stuff was added later on. Also, developers then the other developers in your company will give you feedback. When they start using this, they notice, hey, this is cool, but maybe you could also do this or that, and you can start iterating from there. It's really best to start with the simple tools and then expand later on, rather than like work on something for a month. Maybe in the end, no one uses it. Some other example for tools that we built is for formatting. We have, for example, a very simple tool that formats build files. Everyone sorts dependencies slightly differently with their own logic in their head, but no one knows that logic. And they become a mess, especially with like hundreds of modules. So we have something that just sorts the dependencies and build files. IDE templates are a great way to share code, get started. So for example, some of the code that now Droid creates was initially an IDE template. And then there can be simple command line stuff like taking screenshots or GIFs from a device that make them easily that you can easily copy into like Slack or a pull request to like make it richer, or shorthands for Gradle tasks, which no one remembers, like Gradle app Freeletics lint production API release. Who knows this on top of their head? So like we have just a simple like FL lint, and it will do the right thing for you. Some other observations. In the repetitive task space, developers still need to write a lot of code to glue these individual components together. Like we have the composable, the state machine, and they need to talk to each other. And also this code, while it's simple, can create like also a lot of simple bugs because it's just this repetitive thing. So we want to work on eliminating boilerplate from our app. These are basically the same what I showed before. We have a state machine, we have an example UI, they share like the state and action parameter, and they need to talk to each other. So how does this happen? Actually, we have a second composable that we create for everyone whenever you create a feature module. So this composable like has the state machine, it collects it, it uses composes computer state to put it then into a state container, and then it's just passed to the example UI composable. And then it gets a second parameter, which is a lambda, which then dispatches any action to the state machine. So this eliminates having to connect them from each other and avoids all these simple bugs. Similar to this, I mentioned we have to use fragments. We don't want to. Also, they often cause issues like life cycle stuff, and we also generally want to avoid tying our code to system components, to which we consider fragments, because it makes reworking things or refactoring things harder. So what we did is we also just create the fragment for you. So the fragment basically just has the compose view in its own create view, and then calls the wrapper composable, and then all the setups done. This worked great, but we had some problems with it. If you just create things from a template, they are committed from your code to your code base. So if you want to change things, you need to go into the code base, change it everywhere. If you have 100 features that use the templates to create themselves, you have to update 100 modules and go change the fragment or that wrapper composable. That doesn't really scale. It was great to get started, but at some point, we grew beyond that. Also, we don't really want someone to change the fragment, because we don't want people to write code in the fragment to avoid all the problems. So we created the fragment for everyone, but they still went there and simply added something. Maybe they needed quickly do something in on resume, so they just added a small line to that, and there's nothing preventing them from it because the fragment is still there, accessible to them. So we went a bit further. We had this in the template, and what we did is we created this annotation, compose fragment, and went with generating code out of this based on the annotation. So you put a compose fragment on the composable. It references the state machine so that it knows where the state comes from and where the actions need to go. And then we just generate what I just showed before. So the fragment is generated for you, that wrapper composable is generated for you. So updates become easy, and also people cannot just go into the fragment and simply quickly add something, because the fragment is just generated on the fly. You cannot edit it at all. We also wanted to expand this code generation for views. So far, we only showed composables, so we also need something for our old screens that still use views. And we have this component called renderer. And basically what it does is fairly similar to what a composable does from input-output perspective. So first of all, we give a view binding, so you have it there, you can access it, it doesn't go away, unlike in a fragment. And then you can just call send action to send actions to whoever listens to them. And then you have a render to view method where you get the state and can mutate the views. So call set text or whatever else you need to do based on the state you're given. And then we took this, created a second annotation called add renderer fragment, and then we generate all the wrappers around it as well. So you get a fragment generated, and you get the setup code generated for you so that the renderer and the state machine talk to each other automatically, stop talking to each other when the life cycle goes to certain states, and so on. Updating the generated code becomes super easy, because now it's generated on the fly at compile time, And this is one example of a build time improvement we had recently after just changing what code we generate. So it was between 10 and 40% incremental build times improvements, purely based on the generated code. No need to change anything inside our code base itself other than bumping the dependency of the code generator. So the problem of code is committed, hard to change is completely solved by this because everything is dynamic. It's also making migrations easy. So our code base actually has not one app, but two apps. And the second app was only created in the second half of last year, well after Compose launched, and is actually 100% composed. So this limitation of we need fragments for legacy reasons, they really doesn't apply to it. So what we did is we took this compose fragment annotation, created a second one called compose screen, and this does a slightly different code generation. It still generates you the wrapper composable with all the setup code and some other stuff, but it skips the fragment completely. And all we had to do to migrate this whole app away from fragments is one search replace that replaced compose fragment with compose screen. We want to eliminate even more boilerplate than this. So far, we have covered some stuff. If you remember this first diagram, the state and action setup stuff in the middle is gone, and the fragment is gone. So you don't need to worry about them anymore as a developer. We also want to make this part on the left easier. So like, no one should have to create their own view model just to have configuration change, so like just to have objects survive configuration changes. And also, who likes interacting with Dagger here? I don't see any hands, I think. Oh, there's one. So we want to make this easier. It's not going to away 100%, but like the pain points should go away mostly. And basically what this then gives in the end is like the focus on these three core components shown initially. Like you write your business logic in the state machine, navigation logic in the navigator, UI in the composable. You don't need to touch anything else. So we're generating even more stuff. So we generate a subcomponent that uses scope to annotation to make things scopable, and then it uses Anvil, which is a Square compiler plugin that sits on top of Dagger to create a subcomponent. And if you remember the compose fragment annotation, this always had this scope and parent scope parameters. And those are basically going on the contribute subcomponent annotation from Anvil, which allows some magic, which we'll show later on. Yeah. And then inside the component, we basically expose the state machine. Now we also generate a view model. And this view model does nothing except for creating and holding your generated component. This way, we have a view model. It survives configuration changes. It holds the component, which now also survives configuration changes, which then means anything that's scoped to this component also automatically survives configuration changes. So you don't need any special magic base classes or anything, or like view model providers with like special factories. You basically just add annotations to your classes and can make them survive configuration changes. So as an example, we had our navigator and state machine. And basically, all you have to do is add scope 2 to it. And now they survive configuration changes, which means our state machine doesn't restart when the user rotates the phone. It just keeps running as it was before. We want to show some Anvil stuff, because Anvil in its own also makes it a lot easier already to deal with Dagger. So we have this example of some module. It provides an API through retrofit. And then we have an interface which is implemented right below that. And usually what you would now need to do is you go to the component, add the module to it. And also you need to go to some module and add binds to it so that you can inject the example repository instead of real example repository. Anvil makes this a lot easier. So for the module, you can basically just add this contributes to line with the same scope that you use in the component, or in our case, the compose fragment annotation. And that is it. So you don't need to go manually to the component and add the module there. It's just adding it for you. Same for bindings. So on the implementation class, you can just add contributes binding. You use the scope to say to which component you want to add it to. And then the second parameter is the base interface which you want to bind it to. And with that, yeah, Anvil can do a lot more. We can't cover everything of this here, so there was this great DroidCon San Francisco talk from another Gabriel and Ralf, who's one of the authors. We really recommend checking it out, because if you're using Dagger, Anvil makes it a lot nicer to use and removes a lot of the pain points. And in summary for Dagger, there's not many Dagger interactions left now. So we basically just have these annotations that we still use. So you add inject to some classes you want to make injectable, scope to make something scoped, and for example, survive configuration changes. And then from Anvil, we use contributes binding. And sometimes we still need to create modules to provide something. And in this case, you use the contributes to annotation. So Dagger is getting a lot more pleasant to use, because you don't really interact with it much more than like these 4 annotations. Some learnings for our eliminating boilerplate initiative. Again, start with easy, simple to build tools. We said, like, we pointed out the problems with like having the template not being able to update the code it created easily. We would still start with having a template again. So it worked well in the beginning. It allowed us to iterate easily. And then we figured out what works, what doesn't work, and at some point we switched to the code generation. That's went very well. The problems, you need to be aware of them in the beginning, but it really allows you to start simple and not just invest like 2 months to build some code generation tool initially. Also, isolating system components and the combination with the code generation, as shown, makes updates easily. Like, you can easily like do stuff to improve build times, or also like swap out fragments and remove them completely from your code base without really changing much code in your code base. And now Hannes will talk a bit about domain layer logic.
Yeah, but before doing that, let's maybe start for 1 second, because I know that was a lot of magic, right? And if you have any questions, like he's the dude who knows all this how this magic works. But also just thinking about, you know, view model. We don't have a view model anymore. Like, mind blowing. When he came up first with this idea, I was like, what the hell are you What? But to summarize, where we are coming from is actually coming back to his lean startup principles. Like, we were noticing by observing our users, like other engineers, that they were just creating view models. They are empty. They were just like holding basically another reference to what we get now closer to, like a state machine. And we will talk about that in a minute. But this is the kind of things that I'm talking about with this lean startup principles, or with product development in general, right? It's called product engineering. It's not just engineering or not just product. And a lot of those principles actually belong together, in my opinion, right? Also, the repetitive task. Like, think now about who could spot easily one repetitive task to do on a daily basis in your code base? Might be just creating some classes, might creating just some new kind of config file changes, might be some things like tracking. We didn't talk about that, and we'll talk about that. But for example, we have also a lot of code generation on just doing analytics tracking calls. Like, you as an engineer, you have to pass in 100 parameters just to track something, and now you only have to pass in one element after this code generation magic is happening. Like, just think about that. Just try to observe what you're doing. Just try to observe what your colleagues are doing. Just because it's great for you, it doesn't mean that's great for everyone. And now we're getting a little bit closer to that, more in particular when talking about other KPIs that we were looking at. For example, peer review time. So with domain layer and business logic, that are basically what we want to talk about next. And there were also some other observations when rework rate comes into play. For example, bugs. Like, what you've noticed is it's really complicated to write asynchronous code. And you think, what the hell are you talking about? I'm just making an HTTP request. It works just fine. So shut up your mouth and go ahead. Reusable logic. Like, how often can you reuse something? Totally doable. But how often do you do it then actually de facto? And if it's even feasible to do that for your company, like, does it match different use cases, stuff like that? Before jumping to the conclusion, let me maybe give you a little bit more context about Freeletics. So this is one of our core features, like doing workouts. Like, you see first there's a countdown, there's like 3, 2, 1, then it starts, then you have some time-based exercises, like do for 45 seconds, do climbers. Then you have some rest stuff, where you rest for 10 seconds. Oh, but by the way, you can also skip a rest. Oh, and by the way, then there are different kind of exercises. For example, you do 10 push-ups, but they are not like time-based, but you just have to do 10 push-ups or 10 climbers or something like that. Oh, and by the way, you can also compete with others, like there is some time competition mode with other users. Oh, and by the way, there is also a ton of other type of exercises. Or there is something like if you do the stretching, the time continues to count, but you get like 5 seconds to get into the right position. And now think about how you would do that like from a business logic perspective. And not only about the rework rate or bugs that you could introduce, or number of bugs, but also about your colleagues. Like how complicated would it be to review such a pull request, right? Just think about it. I'm not going to talk about too much about OKRs, I promise, but yeah, I'm an engineering manager, you know. But I'm totally qualified to talk about OKRs, like look how I'm dressed, like I wear a proper business shirt, so that should be all right. We can talk about it as well afterwards. But what we then did is we sat a little bit down with the team that is actually working on this workout flow, and we were trying to understand like what are we actually trying to achieve, right? And at the beginning, Gabriel mentioned that we are having some unidirectional data flow and MVI, let's call it like that. But this is not coming because we like the pattern. We also do like the pattern, but it's coming more from this use case. Like think about this kind of repetition stuff, the countdown, and all this stuff. Like that could be really well modeled as a finite state machine, right? Now, who has written MVI and found like a lot of boilerplate, a lot of kind of confusing code, a lot of Eric's Java, or a lot of coroutine's flow type, and you push something there and over there, and then you need to debug it, and who can understand it as a peer reviewer, right? Now we're talking. So what we came up with is actually a DSL. I'm not saying that this is the only solution, I'm just saying this is what we came up with. So in our example, it's of course a little bit simplified, but in our example, we came up with a library called Freeletics, which by the way is also open source. This talk is not about Freeletics, but just to give you an impression. So this talk, or the takeaway here is more like DSL can help in this context. So for example, you can have something like an in-state primitive in our DSL that would say like, while I'm in the countdown state, or you could have another primitive that says like, while I'm in a repetition exercise state, and so on, right? And then also expressing the logic with DSLs becomes more readable for everyone. Like, it's not that you write your code once and nobody will read it anymore, right? It's quite the opposite usually, and there are plenty of studies showing that. You can just Google it. For example, then you get something like an on-click action or something like that. So the user clicked on it, and then you see, oh, when the user clicks on something, now something should happen, right? Again, check out this repository, more interest in that. Again, it's just about giving inspiration what you can do for you and your colleagues, so to say, rather than about the library itself. But also, there is one other thing, which is about testing. Like, could you imagine like unit tests about the screens and different states and something like that with, let's say, traditional Android development? Like, how readable would that be? But state machines also offer, and I don't want to convince you about state machines, but state machines also offer some great way of doing testing. This is how you would test something. So for example, just testing this countdown state, if it's working properly, you could write it like that with the state machine approach. So what you get is another library called Turbine from the fine folks over at Square. I think it was also mentioned in some other talks before about coroutine testing. It's really a great tool, and it fits perfectly here in. Like, you can do something like, I have a workout, I have initial state, and by the way, now you can also jump to any state as your initial state, right? You don't have to always start your unit test from the very beginning. You can just say, my initial state is now doing 10 push-ups or something like that instead of the countdown that counts 3, 2, 1, right? So now you can write such unit tests in a few lines of code, and you can always then compare, like, is the expected state, like countdown, it starts with 3, then it goes to 2, to 1, what I actually get. And by the way, there are no mocks. There's no kind of multi-threading changes or something like that. That all runs on real production coroutine if you want to. Like, totally up to you as an engineer to decide where it should go. But there is a lot less of boilerplate and noise, so to say, in your tests, and therefore it kind of becomes also now a little bit more documentation. Like, now you see, okay, when I'm in countdown state, this is what expected to happen, right? But how do we know that this DSL is actually good? So coming back again to the lean startup principles and to user interviews, actually, in this case. So what we did is we actually sat down with users, and our users are our other engineer colleagues. We were just observing them. and trust me, doing user interviews right is a science on its own, so I'm not going to do into that, but just ask your designers, ask your user researchers. Like, if there is one takeaway that I can share with you is like, don't ask them for concrete answers. Just let them think out loud. Like, if you are going to ask, like, do you like that or do you like that, then you're always biased and you get like not a real kind of answer. You just have already tricked yourself into what you think is the right answer, right? So, but you can do user interviews, like we did that. We didn't come up with the DSL I was showing you before. I will now show you some intermediate steps, also in the spirit of doing smaller iterations. So where we started was something like that. So we had a get state and a set state kind of parameter. And if you wanted to decrement the counter, for example, you needed to write something like that, okay? So what we did is we just asked, or we sit down when some developers were developing some feature with this library, with this DSL, and we just were listening what they were saying. And they were saying, this is not intuitive. Like, they liked the DSL, they liked how you can now express like your business logic on a high level, but it's still cumbersome to use. Okay, so then we decided, okay, let's maybe try to do something different. So what we did now is we changed the DSL a little bit. Now the set state is gone, and we only have a state, countdown state or something like that. Now it feels a little bit more intuitive, hopefully, but how do we know? So we sat down again with the same person, or with other person, doesn't really matter, other engineers, and we asked them to migrate some existing code to this new DSL. And we were listening what they were saying. And it felt more natural for them, because now it reads a little bit more like you have a pure function, right? You get like an input state, and you return something changed state. And this is what this changed state here is about. There's still a little bit noise. We're not 100% there. But also our users were not telling us that we need to go 100% there to this pure function approach, okay? And then over time, it actually moved more towards this, because one thing that I didn't tell you before, like everything you see here now, the flow redux, it's a highly asynchronously state machine. Like, here is going on a lot of in parallel. But that also comes a little bit with a cost of internal doing things that we don't want to expose to our users, except from this state state class that we need to introduce, and this changed state. Again, not 100% like this pure functional kind of thing, because it does something under the hood. But you as a developer, you don't really have to care. You just write. You just write asynchronous code without knowing you're writing asynchronous code. So yeah, takeaways. DSL are useful, at least for us in the context. That's important for us in the context of Freeletics. User interviews are great, but they are difficult to do. You need to learn and learn as you go. So don't wait until you have read like a big user interview book or something like that. Just start somewhere, but be honest to yourself. It takes time to really do user interviews properly. Iterate, as we've shown before, but also as Gabriel did before, like there were always intermediate steps. We didn't jump from this code generation in one day to what he was presenting. That was over 3 years or so. Also, one thing that I personally found very useful is like writing docs. So while I was writing docs, for example, for Flow Redux for this DSL, there were a lot of things where I was trying to explain that to, like, I was imagining I was trying to think, how would a new user understand this, like outside of Freeletics, outside of any context about state machines. It was like mind-blowing how bad we were designing some parts of our DSL, to be honest. So that's a good exercise as well. But back to the more techy stuff.
Yes. So we had some other things we noticed, is in particular with navigation. So in general, we think navigation is very hard to scale, especially in a modularized code base. And what we also noticed is when we onboarded new people, they didn't really know, like, there's like 100 screens. How do I navigate to screen X? And with that, we wanted to improve it. So two of the main problems we want to solve is we want type safety when we navigate to screens, so no bundle, put string, or like put int, stuff like that. And we also don't want to like pass that on the other side. Same, and then the other part is we want to do this very efficiently in a very modularized code base. So for the first problem, type safety, like Google already provides safe arcs. And it works pretty well to eliminate this boilerplate. So like for each fragment, you would basically get a class like this. This one would like be for navigating to a fragment that shows a tweet. So you just have an item ID parameter, which is the ID of the tweet you want to show. And then in there, they generate some toBundle method, a fromBundle method, so you don't need to deal with that and can just call these two. if we look at this, how it would look for some example screens, if we have a feed for Twitter, then like a tweet screen when you click on an individual tweet, and then a profile screen, you would have like a relationship similar to this. So like you click on a tweet, so the feed navigates to the tweet screen. You can also go to the profile from both the feed itself by clicking on the profile image or from the tweet by clicking on the profile image there. And then lastly, you can also go back to a tweet from the profile because the profile shows the user's tweets. If we look at what save args does, it would basically generate our args classes here because that's where we like define the fragment and the navigation XML, or it would do that in the app module where you cannot even access them. And the problem here with save args that we ran into while we were modularizing our code base is this is a circular dependency if you actually want to use those two classes. So we came up with a different approach that doesn't use save args anymore. So we still have our modules, and basically for each feature module, we created a nav module. So there, for feed, there's a feed nav module, tweet nav module, profile nav module. And if we look at dependencies, oh yeah, and basically, so the args classes are now manually written and in the nav module. And dependency-wise, so like each module depends on its own nav module, so that it can get the arguments that were passed to it. And then you just depend on what you need. So like the feed gets the tweet screen and the profile screen. The tweet screen gets the profile screen as well. And then finally, the profile screen gets the tweet screen. So no more circular dependencies. Also, one problem that's solved is the onboarding issue, because now if you have a feature module where you want to navigate to, you just need to look into the nav module that's right next to it to see, OK, this is the class I need to use to navigate to this screen. Now you might ask some question about this approach. First one is, why not just one module where you put all your nav args into? This would work really well for small apps, I think. So like I wouldn't do this approach for like like app with like 10, 20 screens or something like this. But it has some issues. First is, like, we want to make a change here, like add a new parameter to some existing nav arg, add a new one, something like this. What now happens is, like, this invalidates also all the other feature modules. And since like everything is in a single module, making one small change in the nav module like means all your feature modules need to be recompiled or like at least incrementally built again, which is a lot of overhead if you have a lot of feature modules. So the other part that goes to this, we often had something like this. So like our nav modules like use some small domain classes like an enum that comes from somewhere else, or like some small sealed class where we like want a little bit more type safety than just passing something like a string to the screen. So the bottleneck would become even more because now you need to build some other core modules, then you can build that one core nav module, and then you can build all your feature modules, which kind of goes against this whole thing of we modularize to make our build very parallelizable, and this one module would introduce a bottleneck in the middle. So wouldn't this also introduce a lot of boilerplate? The answer is kind of mixed. So for the nav module itself, that's created by our new module command. So like no one needs to like go and create this module and a build file and put a class into that. So that part is already solved, kind of. The code is still there, but no one really cares that it needs to be created. For the class itself, would you still need to write something like this? And we are back to like writing stuff, putting something into a bundle, pulling it out again, having string keys, stuff like that. No. So we simplified it to something like this. So we still have a data class which gets parameters, and the parameters is basically the thing that you would write manually after the module was created for you. And then it just extends a navroot interface so that we get like a common base class for everything, and then we make it parsable. And with that, it's basically the whole args class. So no to bundle in there, no from bundle. We just have some general extension methods, so you can call navigate to with a navroot class. Just pass it there, and all the bundle stuff is happening internally in that, so developers don't need to care on that side. And on the other side, for example, we have a like fragment require root method to pull out the nufroot class and get an instance of that, so you also don't need to parse the bundle. Our learning here is we love code generation, but sometimes, like in the case of safe arcs, it's not the solution that might be the best for you. So like, you can make things easy enough so that making some small code that is written by yourself is not so painful that you need to actually generate it, and you can like easily just write it yourself. And with that, like, we have a very scalable approach to navigation, and everyone is happy with it. We're using it for like 2+ years now this way, and works really well across our code base. And with that, thank you for your attention. We have 2 GitHub links in case you want to check out some more of what we showed, even though that's not the point of a talk, to just promote these 2 libraries. You should take away, use what we told you as an inspiration. But if you want to look at it, Freeletics is the state machine DSL. We just published 1.0 yesterday, and then in the MAD repository, you can find the code generation and also some of our navigation stuff. Thank you.